Given a polynomial f of x equals x cubed minus 7x squared plus 10x, we're going to find two things. Part A, does roles apply on the closed interval from 0 to 5? And part B, if it does, find C, the x value on the open interval from 0 to 5, such that the derivative f prime evaluated at that x equals c is going to give you 0. Okay, so we'll begin by seeing if the three criterions from note 71 are fulfilled. Then we can apply roles. First of all, polynomial f, you know it's going to be continuous on all real numbers. That comes from note 29. That implies that our function f will be continuous on any subset, in this case the closed interval from 0 to 5. That's taken care of. Next, polynomial f is going to be differentiable on the open. It says closed, but it should say open interval from 0 to 5 because it meets none of those conditions from our note number 43 where we listed the conditions for non-differentiability. Go back and check that out. And then the endpoints x equals 0, you evaluate the function, you get this number 0. Then you evaluate the second endpoint 5 on the function and you get the same answer. And it's not important that the answer equals 0 when you evaluate the endpoints. What's important is that f of a and f of b equal the same number. So all the conditions are met. Thus, Rolle's theorem will hold. And what does it say? It says there's going to be at least one x value, x equals c, on the open interval from 0 to 5, which means somewhere between 0 and 5, such that the derivative evaluated at that x value c will give you 0. Flat tangent. Okay, part B. Now we need to find these c's. There could be more than one. And we do that by taking the derivative of f and setting it equal to 0 and solving for x. Those will be our c values. So take the derivative of the polynomial function given at the top. You'll get 3x squared minus 14x plus 10 equals 0. Try to factor that. You cannot. So we're going to use the quadratic formula with a equals 3, b equals negative 14, and c equals 10. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. So that's equal negative a minus 14, which will give you a positive 14, plus or minus negative 14 in parentheses squared, which is the same as 14 squared, minus 4 times 3 times 10 over 2 times 3. And now it's just a matter of arithmetic, simplifying this. We're eventually going to get down here. Let's move it forward. We're going to get down to the square root of 76. Well, that can be factored as 4 times 19, and when you pull the 4 out of the radical sign, you can pull a 2 out of both of those terms and cancel top and bottom. So we get x equals plus or minus the square root of 19 over 2. Those are our 2c values that are for which the derivative is equal to 0. Okay, so I'm sure it exists, and I've found the two that do exist. I just want to mention something, that these happen to be the only critical numbers for the function f. I didn't call them critical numbers before because recall, critical numbers are either the values x equals c, where the derivative is equal to 0, which these are, or they're the values of c's at which the derivative does not exist. But in this example, there were no values where the derivative did not exist, so we didn't have to worry about thinking about looking for any other critical numbers. But of course, that wasn't what this problem was about. This problem was about Rolle's theorem, making sure it applied, and finding the values that met the criterion that f prime of c is equal to 0.